Let's look at our first method to determine divergence and convergence in series, which is the nth term test. So we have this series. It's an infinite series from n equals 1 to infinity of a sub n. And what the nth term test says is that if the limit as n approaches infinity of a sub n is not equal to 0, then the series diverges. So let's think about this conceptually. If we're summing up all these values of a sub n, and a sub n, the values that we're summing up don't go to 0, we're just summing up more and more and more numbers that aren't 0. So that can't converge. We're just adding more and more numbers, so that's going to go to infinity. So the nth term test can only determine if a series diverges. You can't use it to say that the series converges. If the limit as n goes to infinity if a sub n is equal to 0, well then we can't go ahead and say that it converges. We just can say that it, passed the nth term test. If it fails the nth term test and it's not equal to 0, well then right there we can go ahead and say that it diverges. This is usually one of the easier tests, and it's probably something that you'd like to try out first on a test, because if it fails and the limit as n goes to infinity if a sub n is not 0, well then right there you're done. So let's look at a sample problem. So we have this series, n squared plus 2 over n squared plus 96 from n equals 1 to infinity. So let's use the nth term test. So we're going to take the limit as n approaches infinity of, well, a sub n is n squared plus 2 over n squared plus 96. And that gives us, well, infinity over infinity. And if you guys remember, you'd need to use L'Hopital's. And what that says is we got to take the derivative of the top and the derivative of the bottom, and then we get the limit as n approaches infinity of 2n over 2n. Once again, we get infinity over infinity. So you'd have to do it one more time, use L'Hopital's, and in the end we'd get the limit as n approaches infinity of 2 over 2, which, now the limit doesn't really matter, is just 1. So what we're saying is that the limit as n approaches infinity if a sub n is equal to 1. 1 is not equal to 0. So right there, we can go ahead and say that this series diverges. So as you can see, that wasn't really that hard. We didn't have to do that much work. But remember that you can only use the nth term test to determine divergence. Let's look at another sample problem. And you guys probably recognize this. This is a p-series where p equals 1. And what we know that when p equals 1, the series will diverge, because p needs to be greater than 1 for it to converge. If we use the nth term test, get the limit as n approaches infinity if 1 over n, well, that is equal to 0. So this we know diverges. So this diverges since it's a p-series with p is less than or equal to 1, but it's still passed our nth term test. So that just goes ahead and shows you that if it passes the nth term test, that doesn't necessarily mean it converges. It means that it passes it. It means that it doesn't absolutely diverge right there on the spot, but you still need to use these next methods that we're going to go over to figure out if it converges or diverges.